Meet Maya. She's in 6th grade, she loves math puzzles, and tonight she's staring at a problem on her homework that seems almost too easy. It says, is the square root of 9 plus 16 the same as the square root of 9 plus the square root of 16? Maya thinks, obviously yes. But here's the thing. She's about to discover one of the sneakiest traps in all of math. Let's solve this mystery together. Before we settle Maya's mystery, let's make sure we've got square roots locked down. The square root of a number asks one question. What number, multiplied by itself, gives you this? So the square root of 9 is 3, because 3 times 3 is 9. The square root of 16 is 4, because 4 times 4 is 16. And the square root of 25 is 5, because 5 times 5 is 25. Square roots and squaring a number are opposites. They undo each other. Got it? Great. Okay, so here's exactly what Maya wrote on her homework. The problem asks for the square root of 9 plus 16. Maya looks at it and thinks, hey, I can just split this up. She writes square root of 9 plus square root of 16. That's 3 plus 4, which equals 7. She circles the answer 7 with a big smile. But wait, let's actually check this. And this is where things get really interesting. Let's check the left side of Maya's equation first. We have the square root of 9 plus 16. First, we add inside the square root. 9 plus 16 equals 25. So we get the square root of 25. And what's the square root of 25? It's 5, because 5 times 5 is 25. So the entire left side equals 5. Remember that number. 5 is our answer for the left side. Now let's check the right side, the way Maya solved it. She wrote square root of 9 plus square root of 16. The square root of 9 is 3, and the square root of 16 is 4. 3 plus 4 equals 7. So Maya's right side gives us 7. Now here's the big moment. The left side gave us 5, and the right side gave us 7. 5 does not equal 7. Maya's shortcut doesn't work. This is Maya's big aha moment. 5 does not equal 7, so splitting the square root across addition is simply wrong. It's one of the most common mistakes students make, and now you know why it fails. The golden rule is, always do what's inside the square root symbol first. Add, subtract, whatever's in there, handle it first. Then take the square root. Never split a square root across addition or subtraction. Maya just leveled up her math game. Let's try one more together, so this really sticks. What is the square root of 16 plus 9? Don't split it up. Instead, add inside first. 16 plus 9 equals 25, so we get the square root of 25, which equals 5. Now let's check if splitting gives the same answer. Square root of 16 is 4, square root of 9 is 3, and 4 plus 3 equals 7. 7 does not equal 5. So splitting is still wrong. Same trap, same result. So why doesn't splitting work? Here's the big idea. Square roots are not what mathematicians call linear. They don't distribute across addition the way multiplication does. Here's something cool though. You can split a square root across multiplication. The square root of 4 times 9 equals the square root of 4 times the square root of 9. That's 2 times 3, which equals 6. And the square root of 36 is also 6. It checks out. But addition? Nope. Addition stays inside, always. Ready for a challenge? This one comes straight from the Pythagorean theorem. Find the square root of 25 plus 144. Step 1. Add inside first. 25 plus 144 equals 169. Step 2. Find the square root of 169. 13 times 13 equals 169. So the square root of 169 is 13. Our answer is 13. Now imagine if we had split it. Square root of 25 plus square root of 144 equals 5 plus 12, which is 17. 17 does not equal 13. Big difference. Maya's now a square root expert, and here are the golden rules she learned. Rule 1. Always simplify what's inside the square root before taking the root. Rule 2. Never split a square root across addition. The square root of a plus b does not equal the square root of a plus the square root of b. Rule 3. Same goes for subtraction. Never split that either. Rule 4, the fun one. Splitting across multiplication is allowed. These 4 rules will save you from the most common square root mistakes on any test. Let's do one more quick practice problem to make sure you've got this. Find the square root of 36 plus 64. Remember the golden rule. Add inside first. 36 plus 64 equals 100. Now take the square root of 100. 10 times 10 equals 100, so the square root of 100 is 10. Our answer is 10. If you had split it incorrectly, square root of 36 is 6, square root of 64 is 8, and 6 plus 8 is 14. But 14 does not equal 10. You saved yourself from that trap. Let's spend just a moment on when you can split a square root, because this one is a real math rule. The square root of 4 times 25 equals the square root of 4 times the square root of 25. That's 2 times 5, which is 10. And if you check, the square root of 100, which is 4 times 25, is also 10. They match. So this splitting over multiplication rule is totally legit. Just remember, multiplication yes, addition and subtraction no. That's the key difference. Remember when Maya was about to write 7 on her homework and hand it in? Now she knows the truth. The square root of 9 plus 16 is 5, not 7. From confused to confident, that's the square root journey, and you just made it too. The big takeaway, always simplify inside the square root symbol before doing anything else. Never split across addition or subtraction. If you remember just that one rule, you'll crush these problems every time. You've totally got this. Now go show off your new superpower.